Good morning, students. Myself, Dr. Shantini Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Katankulathu, Chennai. Today, I am going to start a new topic: binary comparator. So, what is comparator? Comparator is basically used for comparison purpose. Okay, so data comparison is needed in digital system while performing arithmetic or logical operation. This comparison determines whether one number is greater than or equal to or less than from the other number. Okay, so digital comparator is widely used in combinational system and is specially designed to compare the relative magnitude of the binary numbers. Now, what is the process of comparison? So, first of all, we will start from MSVs of the number. Okay. So, if MSVs are equal, then only we need to compare the next significant bit. But if the MSVs are not equal, then it would be clear that either A is greater than or less than B, and the process of comparison is this. Okay, so just I am giving, when I will give you the example, then it will be more clear. So here I have given one example, that first of all we will take two bit number, that means A and B, which is denoted as A1 A0 and B1 B0. So if A1 is not equals to B1, then it is clear that A is greater than B for A1 equals to 1 and B1 equals to 0, or else A is less than B for A0 equals to 0 and B0 is equal to 1. At this stage, the process of comparison says this: if the MSBs are equal, then only we will go to the next bit. Okay, so now A1 equals to B1. Okay, then we need to compare the next significant bit A0 and B0 and decide whether the number is greater than, less than or equal to. In this case of comparator, the outputs are basically three. You can already, I think you can already understand that this is LEG. L stands for less than, E stands for equal, and G stands for greater than. Okay, so this is actually the block diagram of the 2-bit comparator. We only concentrate here the 2-bit comparator. So here this is one number A and B. It is denoted as it is a 2-bit. So A1 is 0 and B1 B 0, and outputs are 3: G, E and L. G is greater than, that means A greater than B. E is equal, that means A equals to B, and L is less than, that means A less than B. Okay, so now we are going to the truth table. So it is a truth table where already I have written these are the basically input A1 A0 and B1 B0, and outputs are already 3, that means basically Y1 Y2 Y3, that means A less than B, A equals to B and A greater than B. Now here I will take, there is a 4 inputs, that means combination will be 2 to the power 4. Okay, so 2 to the power 4 means 16 combinations will happen. Okay, so now 0 0 0 0 and it will end 1 1 1 1 combination. So first of all we have to start the comparison in this way. We will check first we will check MSBs, that means A1 and B1. So here in the first case A1 and B1 both are 0 0. So we have to, as both are equal, then we have to go to the next bit, that means A0 and B0. So here we can also see that A0 and B0 also same 0 0, that means A equals to B. So here I have written 1. Okay, then next part. Okay, that means 0 0 0 1. So first of all we will compare with MSB. Both A1 and B1 is 0 0, that means we have to go for the next bit, that means A0 and B0. So you can see that A0 is 0, B0 is 1. So you can easily understand that A less than B or B greater than A. So here I will put the 1. Okay, then next 0 0 1 0. So first of all we will check MSBs. So A1 is 0, B1 is 1. So from the first by using the image views we can understand that a less than b. So I have written here 1, okay, and other position it is 0 0, okay. Now next 0 0 1 1, okay. So again we will compare the MSB 0. This is A1 is 0 and B1 is 1. So in the first case also we will get our answer that A1 is less than B. So again we will put here 1, okay, A less than B, another position 0 0. Now next 0 1 0 0. So both A1 and B1 are 0 0. So we have a doubt that whether this number is greater or equal to or less than. So we will go to the next number 1. That means A0 is 1 and B0 is 0. So now we can easily understand that A greater than B. So here I put a 1 value, okay. So A greater than B. Now next time again 0 1 0 1. Here both A1 and B1 0 0. So we will go to the next bit, that means A0 and B0. Here also both are same, A1 1. So A and B are equal. So 0 1 1 0. So first bit, that means MSB 0 1. So it is actually A less than B. So here it is 1. A less than B is 1. So again 0 1 1 1. Okay, so first of all we will check MSB 0 1. So in the first case we can understand that A less than B. So here also A less than B we will put 1. Okay, other position 0. Then again 1 0 0 0. So first we will check MSB's A1 1 and B1 0. So we can understand that A greater than B. So here we will put 1. Okay. Next 1 0 0 1. So again MSB's 1, A1 1 and B1 is 0. So here also the number A greater than B. So here we will put 1. Then again 1 0 1 0. Okay, so here both MSBs and LSBs are equal. So here A equals to B. Then next 1 0 1 1. So both MLSBs are equal, so we will go to the LSB. So here A0 is 0 but B0 is 1. So here A less than B. So here we will put 1, other position 0. Then 1 1 0 0. Okay, so 1 1 0 0, A1 and we will first compare A1 and B1. So here we can easily understand that A1 is 1, B1 is 0. So A greater than B. We will put A greater than B1, other position 0. Okay, then 1 1 0 1. Again here A1 is 1 and B1 is 0. So again A greater than B. We will put A greater than B1, other position 0. Then 1 1 1 0. Okay, so here first of all we compare MSB. That means both A1 and B1 are 1. So we have a doubt whether this number is greater or equal or less. So we will go to the next step. That means A0 will compare A0 and B0. So here also A0 is 1, B0 is 0. So we can easily write that A1, that means A greater than B. Okay, so here A greater than B I have already put 1, another position 0. Then 1 1 1 1. That means all MSBs and LSBs are equal. So we will here actually A equals to B. Now we have to find out what is the simplified value of A less than B, A equals to B and A greater than B. Okay, so for this purpose we will basically use K-map. Okay, so here this is the 4-bit number. So 4-bit means 2 to the power 4. That means here 16 cells will be there. So based on these A0, A1 A0 and B1 B0 value, for the case of A less than B, we will consider only this column's value. Okay, and when we will put the K-map value for A equals to B, we will consider only this value, and for A greater than B, we will consider only these values. Now this is the K-map simplification. Okay, so here also A1 is 0, B1 B0. So according to 0 0 0 0, here 0. First just I check once again 0 0 0 0. for a less than b it is 0. Okay, so here we will put it is 0. Then 0 0 0 1, 0 0 0 1, it is here 1. So we will check again 0 0 0 1, it is 1. So we have to put here 1. In this way we will fill all the 16 cells. Okay. Now we will simplify the K-map according to the K-map rule. So if you have a doubt any in the K-map process, you just go and visit my K-maps simplification process. There are 4 I think videos are there. So just go and check and you will be very clear for this K-map process. So now first of all there is a 1, actually 4 ones are there, so we will form a quad here. There are 2 ones, so we will make a pair, and here also 1 1 and here also 1 1, we will make a pair, and based on this quad and pair value we will simplify this equation y1. Okay. Then coming to a greater than 1, a greater than b, sorry, a greater than b. So here a1, a0, b1, b0. So same thing. So it is also, first of all we will concentrate here a greater than b. That means 0 0 0 0 is 0. Okay. So we will put here also 0 0 0 0 0. Okay. Then 0 0 0 1 also 0. Just check once again, 0 0 0 1, it is also 0. So we will put again 0 0 0 1, it is 0. Then in this way we have to fill all the other cells also there. Then using the K-map method we will actually simplify the K-map. Okay, this K-map here already there are 4 ones, so we will form a quad. 2 ones, so we will form a pair, and there is 1 1 and there is 1 1, we will make a pair here also. Okay, and finally the simplified a greater than b result is this. Okay. Now for a equals to b, same process we will follow. In that case we will only concentrate on these value. Okay, because these are a equals to b. Okay. Now we will put all the value based on this column, and then there is no formation of quad, no pair, so we will just simplify this value we have to write based on the K-map rule, and this is the final expression. Okay. Now this expression we will simplify more, because we will from here we can easily take a common. Okay, so from this actually this part, this first part, we will take a0 and a0 bar and b0 bar, we will take a common from here, and also from this value. Okay, there is also a0 bar, b0 bar. So if I common a0 bar and b0 bar, so inside the bracket there will be a1 bar, b1 bar plus a1, b1, plus next from these two value we will take common a0, b0. So inside the bracket there will be a1 bar, b1 bar plus a1, b1. So finally we will the answer will be a1 bar, b1 bar plus a1, b1 into a0 bar, b0 bar plus a0, b0. So this is a1 x naught b1 and this is a0 x naught b0. Okay, this is the final equation. Okay, this a1 and b1 x naught form, and here also a0 and b0 x naught form, and both are basically in a AND form. Okay, so now we have to draw the circuit diagram also. The question will come in this way, that what is the comparator, and design the 2-bit comparator with respect to the based on your principle. Okay, so first of all you have to write what is comparator, what is 2-bit comparator, and how we will compare. For this purpose you have to design the truth table, and then you have to follow the K-maps and find out what is the simplified equation of a greater than b, what is the simplified equation of a less than b, and also a equals to b, and then you have to draw this diagram. Okay, so based on the diagram actually we will find out all the result. Okay, so this is here this is actually a less than b, so here A1 bar, A0 bar, B0. So this is, you can see, A1 bar, this is A0 bar, and this is B, okay, V0. And here actually A1 bar, it is A1 bar and B1, okay, and then A0 bar, this is A0 bar, then B1, and then B0. So here 3 AND gates are basically used, and after these 3 AND gate we will use a OR gate, and final expression will be all these terms summation, okay. And then next part is A equals to B. A equals to B's result is for this A1 XNOR B1. So we will take basically A1 and B1 and passing these two inputs through a XNOR, and it will get the output A1 XNOR B1. Similarly, A0 and B0, passing these two input through another XNOR, and it will produce A0 XNOR B0. And then these two XNOR are in the basically are the input of the AND gate. So final output will be A equals to B. That means A1 XNOR B1 into A0 XNOR B0. Okay, then we are coming to the A greater than B, that here also A0, then B1 bar and B0 bar, and here A1, A0 and B0 bar, and then A1 and B1 bar. So we will also use here 3 AND gates, and after the AND gates input, it will pass through the OR gate, and we will get A greater than B value also. So thank you so much, students. If you have any doubt, you give me this question in a comment section. I'll try my best to solve this question. Thank you so much.